Hi, I'm Divya Kothandaraman. I'll be presenting our paper titled Salad, Source-Free Active Label-Agnostic Domain Adaptation for Classification, Segmentation, and Detection. We consider the challenging task of adapting a pre-trained source domain network to a target domain with a small budget for annotation in the target domain and a shift in the label space. Further, the task assumes that the source data is not available for adaptation due to privacy concerns or otherwise. We postulate that methods designed for this problem need to address two facets. One, effective knowledge transfer from the pre-trained neural network to the target network using a small set of annotated samples, of course without any negative transfer, which can in fact degrade performance. And second, intelligently choose samples to annotate to facilitate knowledge transfer as well as span the spectrum of samples contained in the target dataset. Salad holistically addresses two key challenges of the problem statement via two complementary components: the Guided Attention Transfer Network, or GATN, for knowledge transfer from the pre-trained network to the target domain, and an active learning algorithm, HAL, for mining samples from the target domain for annotation. Knowledge transfer. GATN transfers relevant knowledge at the feature level from the pre-trained network to the target network. GATN uses a transformation network to modulate the features of the pre-trained network in alignment with the target domain, followed by guided attention for selective distillation to the target network. The target network guides the knowledge transfer via label samples selected by the active learning heuristic. The next is mining samples. The effectiveness of GATN depends on the samples mined from the target dataset. While it is important to choose samples that are similar to the distribution familiar to the pre-trained network for effective knowledge transfer, we need to ensure that the chosen samples are informative to the network with respect to the target dataset. To do so, the active learning heuristic fuses transferability from the pre-trained network as well as uncertainty with respect to the target network. Results at a glance. We conduct experiments on image classification, document detection, and segmentation. Under classification settings, Salad, even without access to annotated source data, performs similar to or better than prior active domain adaptation methods that use large amounts of annotated source data that can be of the order of 100,000 samples. Further, we conduct experiments on MNIST under two distinct cases of shift in label space and show that Salad can achieve at least 99.4% of the accuracy obtained when there is no shift in label space. The Salad can handle shifts in label space. Our experiments on CityScapes of semantic segmentation at various budgets reveal an improvement of at least 5.57% over source-free fine-tuning. Finally, we conduct experiments on document layout adaptation from PubLayNet DSSE, where there is a shift in output label space, and Salad imparts a relative improvement of 31% over fine-tuning. To recall, our method has multiple benefits, that it's task-agnostic, label space agnostic, it does not require any source data, and it is comparable or outperforms state-of-the-art methods that use large amounts of annotated source data. Limitations in future work. The attention weights can make the neural network memory intensive, and the active learning weighing scheme that we use is quite simple. Further, it can be extended to other domains in natural language processing for tasks such as question answering and text classification. Thank you.